Hi everybody, my name is Natalie Villafranca. I'm in Thursday Lab Group B, and today I'm going to be talking about recrystallization, which is the lab that we did last Thursday. So to start off with, what is recrystallization? So recrystallization is used to purify solids. In last week's lab, we used it to purify the acid acetanilide from salicylic acid. The initial salicylic acid concentration was 5%, and we attempted to lower it down to 3%. The way that it works, this is going to make a lot more sense when I explain the methods, but the way that it works is basically when the compound is dissolved, the desired compound is insoluble and the impurity is soluble. So when it's heated and allowed to cool, the compound that is insoluble will turn into crystals, while the impurity remains in liquid form. So while vacuum filtration is done, the desired compound, in this case acetanilide, which is in crystal form, stays in the filter, while the liquid containing the impurity goes down the vacuum and into the glass container. So for this procedure, I used 50 mils of water to start off with, and I put them in a 50 ml beaker, and then I also added a stir bar, and I used a watch glass as a lid to prevent a lot of water from boiling out, and then also for it to boil a lot quicker. So then once that water was boiling, I added about a gram of acetanilide with the impurity. And so I let that boil until the solution was completely clear and you could no longer see that acetanilide powder. And so then what happened to me was it oiled out, so I had to add more water. So that took a little bit longer because that water had to reboil and that solid had to redissolve. So then once that happens, once you're done, once your solution's clear, then you take it off the heat, heat plate, and you allow it to cool, and then while it's cooling, it'll turn into crystals. So that picture right there on the right is a photo of my crystals. I thought it was really cute, so I took a picture of it. So it crystallizes like that. You want to leave it as long as possible to get as many crystals as you can. And then using that little scoopula, you pour the crystals into the vacuum filtration apparatus, which is right there on the left, that way. And so the vacuum will vacuum down the water into the suction flask, and then the crystals will stay right there in the funnel with the filter. And so also, to get as many crystals as possible out, you can continue adding water into the beaker and then scoop out to get as much as possible out. And so then once all of the crystals were poured out of the beaker and filtered correctly, the liquid at the bottom was the impurity, and the crystals on the top were the acetanilide, which is what we wanted, with a lower impurity, so probably around 3%. And so I weighed, after all of this was done, I took the funnel with the crystals in it, and I put the crystals in a vial that I had already weighed, and then I weighed that vial with the crystals to find out how much yield I had. I had 69% yield, which I thought was pretty good because we wanted a 50% yield. I maybe could have increased my yield if I hadn't dropped some crystals. Some of my crystals fell out of my beaker with like the hood. It blew them away, or maybe I missed a few crystals in there, but it probably wouldn't have made too much of a difference. So that was probably a cause of experimental error on that part. But overall, it was a pretty successful experiment, and it was fun to do. Thanks for listening.